Okay, let's take a look at this last section in Chapter 4, Section 4.5. And in this section, what we're going to do is solve inequalities involving quadratic functions. And our main focus here is going to be a visual solution. So what I mean by that is, let's take a look at this first example, where it says, solve the inequality x squared minus 4x minus 12 less than or equal to 0. And then we're going to graph the solution set. So the first thing we want to think about really is if we were to graph this parabola. Now, so if we were to graph f of x equals x squared minus 4x minus 12, that's a quadratic function. So we could pretty easily find the vertex, an opposite of b over 2 times a. Right? We can see that a is positive, so it opens up. And in particular, we could find, let's say, x-intercept. So we could set this quadratic equal to 0 and find x-intercepts. And if we were to go through that work like we did in prior sections, in 4.3 we did quite a bit of that graphing. I'm just going to leave that work out, showing you that work. But I could definitely do all that work with pencil and paper. And then I could get the graph of the parabola, excuse me, which looks something like this. So here is the vertex of the parabola, and here are the two x-intercepts. And again, we see the leading term is positive 1, so the parabola opens upward. Now again, obviously, you have graphing technology that can sketch these functions for you very quickly. We could use our TI or Desmos.com. But one thing I would highly recommend as you go through these problems in my math lab is that you practice doing the work by hand and then use the technology to check your work for yourself. All right? So anyway, here's the sketch of the graph, and what we're wanting to do is find where this parabola is less than or equal to 0. All right, now visually speaking, think about what we're doing here. We're taking the y value, right? These are the function values. These are the y values of the graph. We're finding where the y values are less than 0 or where they're negative. Right? So again, we're focusing on where the y values are negative, where they're less than 0. And if I kind of shade or sketch on the graph where that's going to occur, that's going to be right here. Right? Here's the parts of the parabola where the y's are negative. Now, keep in mind, when I come back and look at this inequality, I want the x values that make that true. So visually, here's my visual interpretation of this inequality. My visual interpretation of this inequality is that I'm going to graph this parabola y equals x squared minus 4x minus 12, and I'm going to find where the y's are less than or equal to 0. But I want the x values that make that true. So when I shade where the y's are negative, I'm wanting all of the x's here, right? What are the x's that make that true? So you can see for this particular graph, any x between the x-intercepts. So the x-intercept is negative 2, 0, and 6, 0. Those are my two x-intercepts. So any x between those two x-intercepts is going to solve this inequality. Right? So here's the graph of the solution set. So when this problem said graph the solution set, this is what they meant. They meant sketch the solution on a number line. So any x between negative 2 and 6. And in fact, I'm going to put brackets at negative 2 and 6 because negative 2 makes the y value 0 and 0 equals 0, right? That satisfies the inequality. And then 6 is also included in the solution set because of the or equal to. And then any other x value in that interval is part of the solution set, right? For example, if I pick x equals 0 right here, I can see the y would be negative 12, right? See, look back here at the inequality, 0 minus 12, right? So if I'm plugging in 0 for x, 0 squared minus 4 times 0 minus 12, I'm going to get negative 12 as the y value, and negative 12 is less than or equal to 0. And in any other x I pick, and in particular, I'll pick x equals 2 because I have that on my graph. But if I pick x equals 2, I'm going to have 2 squared, which is 4, minus 4 times 2, so that's 8. So I got 4 minus 8 is negative 4, minus 12 is negative 16. And negative 16 is less than or equal to 0. Negative 16 is less than or equal to 0. So any x I pick in this interval will solve this inequality. So there's my solution as an inequality form, and then there's my solution as an interval form. All right, so again, the key here, what we're talking about in this section, is we really want to solve this inequality graphically. We already discussed in great detail how to sketch these parabolic functions, these quadratic functions. So we're going to sketch those parabolas. We're going to find the vertex, determine the direction they open, and we're going to plot the x-intercepts. And one thing we're going to notice here, let me point out to you on this example, and then we're looking at another example, the x-intercepts are always the place where the graph transitions from having negative y values to having positive y values. So the key to solving these inequalities is we're going to get 0 on one side. I think that's the easiest approach. We're going to get 0 on one side, and we're either going to be looking where the graph is less than 0, or where the y's are negative. We're going to be looking where the graph is greater than 0, where the y's are positive. Right? So these x-intercepts are always going to be really important points for us as we do these problems. So let's take a look at this inequality. So this is another quadratic inequality. It says 2x squared is less than x plus 10. And it says graph the solution set. We're going to give it as an interval as well. Now, there's technically two ways to do this. So let's talk about both methods. All right? The method that I personally prefer is getting 0 on one side and finding the x-intercepts. So what I'm going to do is I'm going to get 0 on one side of this inequality. Right? So I'm going to write the inequality in this fashion. I'm going to say subtract the x over, subtract the 10 over, and I'm going to have 2x squared minus x minus 10 is less than 0. Okay? So when I do that, to me, the simplest thing to do now is we graph this parabola. So I graph y equals 2x squared minus x minus 10. And if I were to do that, and if I were to find the vertex, here's my vertex, and if I were to find the x-intercepts, then I would be able to plot those points of interest. Right? So the first thing is we're going to find the vertex. Right? There would be the work of finding my vertex. I'm going to find the x-intercepts, right, where the y equals 0. And then we're going to find where the y is negative. Right here, we're looking where the y is negative. So really similar to that prior example, right? Here's where all the y's are negative. So we're actually looking between the two x-intercepts in this particular case. So between -2 and 5/2 is where this inequality would be satisfied. So just point out to you, right, here's my solution as an inequality between -2 and 5/2. The only thing I want to be careful of here is point out to you, my original inequality is a strict less than. So I don't have or equal to 0. So I'm not going to include the endpoint. I'm not going to include -2 in my solution set. Right? So notice how we put a parenthesis here graphically. So between -2 and 5/2, and I don't include with a bracket. Right? And there's my interval notation. Okay? Now, keep in mind, this is interval notation here. This is not an ordered pair, right? This is the interval of the inequality. All right, now let me stop for a sec. So this is method 1. This is my preferred method. I think this is the better way to go because it allows me to focus on the x-intercepts. So I get everything on one side. So when I see this inequality given to me, I just subtract everything to one side, and I get 0 on the other side, and then I graph this parabola. So I'm going to find the vertex of this parabola, I'm going to find the x-intercepts of this parabola, and then I'm going to solve the inequality from that point. Now there is another way to do this, and the book shows you that other method, and let's discuss that for a second. Okay, so let's take a look at this example and talk about method 2 then. So method 2 basically is I'm going to graph the left-hand side of this inequality. I'm going to graph the right-hand side of this inequality, and I'm going to compare those two graphs to each other. So notice in this picture, the left-hand side of this inequality is y equals 2x squared. That's graphed in blue. Right? And the right-hand side of this inequality is the line y equals x plus 10, and that's graphed in this red. So in essence, what I'm going to do is graph both sides of the inequality and compare them to each other. So here's my inequality. I'm going to graph the left-hand side, y equals 2x squared. I'm going to graph the right-hand side, x plus 10. And in this case, I want the first graph to be less than the second graph. So I'm looking where y1 is less than y2. So you can see on this graph over here on the left, let me pick x equals 0 as an easy point to point out to you. Notice when I pick x equals 0, x plus 10 is greater than 2x squared, or vice versa. 2x squared, the y value, is smaller than the y value here. So if I were to plug x equals 0 into my inequality, I'm going to get 0 on the left-hand side, and I'm going to get 10 on the right-hand side, and 0 is less than 10. So this is just another approach. Instead of looking specifically at the x-intercepts of a parabola, I'm going to compare both sides of the inequality to themselves. Now, the only difference here really is visually is that I need to find these intercepts, right? These points of intersection, if you will, right? So if I'm going to find these points of intersection, what I'm going to do over here in step 2, I'm going to put each equation equal to each other. So I'm going to set 2x squared equal to x plus 10. I'm going to solve that equation. Now when I subtract x to the left and subtract 10 to the left, I'm solving, oops, that's a typo. I'm solving 2x squared minus x, this should say minus x, minus 10 equal to 0. So let me fix that real quick. Right, this should say minus x minus 10 equal to 0. All right. Now, if I solve 2x squared minus x minus 10 equal to 0, I'm going to get those two solutions, negative 2 and 5 halves. Right? And this is going to give me the same solution as we got doing the first method. All right? So again, if I look, let's say, between these 2 points of intersection, the blue graph is lower than the red graph, and so we're solving this inequality. If I look outside these points of intersection, for example, if I look at negative 3, now the blue graph is greater than the red graph, and that's not what I'm wanting for this inequality. So those would not be my solution intervals. Okay. All right, let me caution you real quick. The 2 examples that we have looked at so far have involved the solution interval being between the 2 numbers. That's not always the case, right? This solution was between the 2 numbers, and the very first example was between the 2 numbers. That's not always the case. Be careful about that, okay? So let's see, I think the third example we'll actually look at the solution maybe being outside the intercepts. Right? So here's an example here as well. Let's take a look at this. Okay, so what I specifically did with this example here was remove the equation, and let's look specifically in a visual interpretation. All right, so in this example we're looking at where is g of x less than or equal to 0. So here's the graph of g of x over here to the right, and we're looking where basically the y values of this graph are negative, where they're less than 0. Now again, even though I'm looking for where the y values are negative, I want to know what x's make that true, right? What x's will make the y values less than 0. So first of all, what I like to do is I like to kind of shade. So where are the y values negative, right? So on all these parts of the graph right here, the y's on every single point here are positive. And that's not negative, right? But down here, all of these y's, every point on this graph, here's a point, here's a point, here's a point, here's a point, right? All of these points have y's and are negative. So every point along this segment of the graph is negative. Right? And then ditto over here. All of these y's are negative as well. So let me plot those, and let's say those are negative as well. All right, so again, I want the x's that correspond to that piece of the graph. So let me change color. So for this point, here's the x that corresponds to it, right? For this point, here's the x that corresponds to it, right? For this point, here's the x that corresponds to it. So every x to the left of that x-intercept is in the solution interval. And ditto over here, right? Here's a y that's negative. Here's the x that makes that true. Here's the y that's negative. Here's the x that makes that true. So every y value out here is in the solution interval as well. All right, now, so here's my x-intercepts. Looks like -1 and 1 are my x-intercepts. So the only thing I really need to determine then, right, so I got -1, from negative infinity up to -1. That's one of my solution intervals. And then from 1 out to infinity. So the only one of these that matches is this one here or this one here. So from negative infinity up to -1 and from 1 to infinity, negative infinity up to -1 and 1 to infinity. So when you look at both of these solutions, notice this one does not include the endpoints. This one does include the endpoints. So which of these do I want? All right, so that comes back to this right here, right? So if my inequality is less than or equal to, right, then the equal to 0 occurs at those intercepts. So I'm going to use the brackets. Right? So letter C is going to match that situation for that inequality. All right, so in this example, this is basically what the book calls method 2, right? So where we're going to look at points of intersection and we're going to compare the two graphs to each other. So for this example, we want f of x to be less than g of x. So if we want f of x to be less than g of x, basically what we're looking at in this case, here's g of x. So g of x is this line right here, right? And f of x is this parabola. So we want f to be less than g, right? So visually we want the f to be smaller than g. So we want the parabola to be below the line. Excuse me. So between these 2 points of intersection, that's not the case. The function g is less than the function f, right? So if I pick x equals 1, g is smaller than f. And that's not what we want over here, right? We want f to be smaller than g. So it looks like to the left of this point of intersection, that's where we want to be. G is bigger than f, right? That's what we want. So looks like from 1 out to negative infinity, we're going to have that happen, from -1. And then looks like from 3, so 3 is the point of intersection, out to infinity, we're going to have that. So from negative infinity up to -1, that's going to be true. And then from 3 out to infinity. And that's going to be our solution set. So in this case, the strictly less than symbol that we have here tells me I don't want the or equal to option. Right? So I'm not going to have brackets, I'm going to have parentheses. So it looks like I'm going to use these parentheses here for letter A. All right, so look, one last example here, and just to kind of put it all together, right? Referring to the graph given to the right, the letter A says, what are the x-intercepts? So those are going to typically be the points of interest for us here, especially when we're comparing to the number 0. Right? So the x-intercepts we can see here are -4 and -3. So there's my two x-intercepts. I'm listing them as ordered pairs. So when x is -4, comma, y is 0, and when x is -3, comma, y is 0. Right? There's those two ordered pairs. And then letter B says, what's the solution to the inequality where f is greater than 0? So again, that's where the y is above the x-axis. So again, to the right of this x-intercept, the graph will be positive or greater than 0. To the left of this x-intercept, the graph will be positive. We just want to make sure we always list these chronological. So for this piece of the graph, I'm going to always go from left to right. So I'm always going to say from negative infinity up to -4. And then from -3 out to infinity. Right? So there's those two intervals, solution intervals, for f being greater or equal to 0. Again, because I have the or equal to, I'm putting the brackets at each of those x-intercepts. And then for the strictly less than 0, right, I'm obviously going to be looking between the x-intercepts. That's where the graph is negative. So I'm going to say from -4 to -3. And again, no or equal to, so I don't use parentheses. I don't use brackets, I only use parentheses. All right. So what's nice here, this last section in chapter 4, this is a good visual way to graph and solve inequalities. So one thing I'm going to keep in mind here as you start to prepare for the chapter 4 test, there's a really nice summary, like chapter review in my math lab. Right, so once you're in your e-text within my math lab, over here on the left, I click on chapter 4 and I could come all the way down. There's a chapter review activity. And just to remind you, what this chapter review does here is, I think it really starts on the next section, right? Gives you a nice kind of review summary of the topics and even points out to you the pages and examples you should go back and look at. Gives you some practice exercises that you could work on. Now, keep in mind that I have built a review activity in my math lab for you. I would recommend using that. But if you want some additional practice, the textbook does provide that for you.